So what we have here is a hand crank generator that came out of a flashlight. We squeeze the crank and gearing causes a flywheel to spin, which causes a magnet to move inside of a wire coil. And the connections here are going up to an oscilloscope, which is a device for measuring sine waves and actually other sinusoidal periodic and non-periodic waveforms. Let's crank the generator and watch what happens on the oscilloscope. Ignore the spots where it's going darker and lighter. That's an artifact of the measuring system. It's the linking of this oscilloscope along with the scan rate of the camera. So basically ignore the dark light stuff and look at the sine wave. Faster we crank, the more amplitude we get and the faster the sine wave. So let's crank it good and fast. Going good and fast. Here's a pretty large sine wave. What is that? It was like about, looking at the oscilloscope here, it was approximately 10 volts peak to peak. So from a flashlight standpoint, that would be plenty to light a bulb. Notice also that the frequency is dependent on how fast we crank. Crank as fast as possible to get a higher frequency. Then as it coasts down, amplitude and frequency both slow down or get lower, decrease. So there we have it. Simple demonstration of a hand crank AC generator.